So we're going to look at 30, 60, 90, 45, 45, 90 triangles. And these are the special right triangles. I might do this up here just for our reference purposes. Let's say that I have a 30, 60, 90, right? One of the things you have to know is where do the formulas go centered around that triangle? Well, think of this. 30 degrees is the smallest angle, and across from that has to be the smallest side, and the smallest side is n. 90 degrees is the largest angle, and across from that is the length of the hypotenuse, which is the longest side, and that's double the shortest side. So n, 2n, and then that just leaves the n squared of 3 that is always across from the 60 degree. Now, what I've told students that has asked for help is have this as a post-it note or something on your desk that you can look at, right? We can't tell you to not use notes. So if you're taking a test, here you go. All right. Well, the reason why I do that is because I have an equilateral triangle here. Actually, I think there's 2 marks missing. But if this is, no, not really, because if this is 60, here's 90, this angle has to be 30. And because of linear pairs, this has to be 90. So that means this has to be 30. So that means I have a large equilateral triangle, which means this side length here is the same as this side length here. So that automatically tells me that z is equal to 24. And then notice y is across from the 30. Well, wait a minute. If the 24 is 2n, that means y definitely is half of that at 12. Now, if you don't really like this setup, here's what you could do. You could redraw half of the triangle and label 24, y, and x. That's one of the skills that I think is pretty valuable, is just being able to pick apart a triangle. So we got a 30, 60, 90, and then if that's the case, across from the 30 is n, across from the 90 is 2n, and across from the 60 is n square root of 3. Well, in doing that, only one of them results in a problem that I can solve. If I solve for n and I divide by 2, I get n being 12, which means if n is 12, then that means y is 12, and that's what we concluded up here. But then x is 12 times the square root of 3. So you could do all that without drawing this separately and without putting your formula around. But I know all 3 sides then. By the way, this little dotted line, it's called the altitude of a triangle. We didn't really study that, but altitude is the same as height. So it's how tall that triangle is from the base straight up. All right, so that was 30, 60, 90 triangles. Then I'm going to come over to this one, and we're going to look at, it's a right triangle that is isosceles. Well, if it's isosceles, the base angles are the same. And if the base angles are the same, then it has to be a 45, 45, 90 triangle. So what I'm going to do is just kind of quickly sketch our formulas. If it's 45, 45, 90, then what do we know? We know that these 2 side lengths, because they're both across from the 45s, are the smaller side lengths, and they have to be equal. So n, n, and then the formula we learned before from the Pythagorean theorem was n squared of 2. So there's my formulas for a 45, 45, 90. If you want to, you can place those formulas around this image here. All right, and I've always said try to use a separate color. I like to use red as my formula marker. So across from the 45 is n, across from the other 45 is n, and always across from the hypotenuse of the 45, 45, 90 is n square root of 2. Well, what that does is that tells me exactly what n is equal to. I don't have to solve anything, I already know. So if this is 12 square roots of 2, then r is 12 square roots of 2. And then all we have to do is plug 12 square roots of 2 in for n and multiply it by another square root of 2. Well, you could do this in your head if you want, but the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2, and 12 times 2 is 24. So I now know all three side lengths of this triangle. Which, by the way, I also know all three angles. On Monday, we're going to talk about solving a right triangle that says find all three angles and all three sides, when in actuality, we've been doing that all along. All right, really quick, I want to mention just about your quiz. So I released the answers, or I take that back. I made it available last night so you can now see which problems you got wrong. I didn't do that initially because we had a bunch of kids still taking it. But reminder, you can take that quiz up to 20 times and keep working through it. The hint that I'll give you all, and I don't remember which problem, but there was one problem that you had to read very carefully. And it said, what is the length of all three wires or something like that? Not the length of one, but what is the length of all three? So you might have done the math right, you didn't read the problem carefully enough. So just careful. Some kids were getting frustrated with that problem, which tells me that's a good problem. Okay, do not expect to see a change if you do not make one. I like that quote. All right, today, and I know I've said this before, but today could be the biggest day of your geometric careers, meaning you will be using this skill at every level of math for the rest of your life. Now, we're going to teach you something that you may have already heard of, but we're going to study trigonometry. All right, so trigonometry is just breaking down tri meaning three. So we have three sides and their measures. That's kind of what trigonometry is talking about, is it's like three-sided measures, or what we're going to be looking at is ratios. So if I have a right triangle, the ratios of sides are going to be true for every single triangle that has the same acute angle and a 90-degree angle, because they're similar by angle. We're not going to get a lot into that, and we have a pretty heavy day. Notice the title is 7576, so we're going to do parts of both of them, but it really gels nicely together. Okay, I would like you to draw this piece here, but we're going to drag and place these pieces into the correct spots. So what do we mean when we say trigonometric ratios? Well, the ratios are based off of the 90-degree angle and what's called a reference angle. I might see if I can type that in there really small. I don't know if that's too small to see. I typed in the word reference angle. Now, why do I call this a reference angle? Because it's the angle that we're going to make reference to, right? And it's a acute angle. It's never, ever going to be the 90-degree angle. So what I want to do then is I want to drag these words into the correct spot. And probably the easiest one out of all these is the hypotenuse. Right? Hypotenuse is always across from the 90-degree angle, and it's always the longest side. We've talked about that before. And then we've talked about the two side lengths that make up the 90-degree angle are called legs. Right? So that's nothing new as well. However, now we're going to actually call them opposite and adjacent. Now, this is the important one, the opposite side length. And what we're calling opposite is opposite of the reference angle. So if I take this angle and I go to the side length opposite of it, it's the side that is not touching the given angle. All right, so if this is my reference angle right here, this acute angle, this would be considered the opposite side. The adjacent side is the side length that actually helps make up that angle with the hypotenuse. Now, what's important is what happens if I switch the reference angle to this angle right here. What stays the same and what changes? Okay. So you don't have to write this one down. I want to just I want to go through this fast today. So let's say I have this picture right here. Now, first thing I'm going to do is actually make this just a little bigger. What if I change my reference angle? Right? What if I throw the reference angle to a different one, or the triangle is flipped around? Well, we can still say, okay, the hypotenuse is always across from the 90-degree angle. And then we know the legs are the two sides that make up that 90-degree angle. And then here's the opposite. Opposite is always across from the angle we're referencing to. And the adjacent is always the leg that makes up the angle with the hypotenuse. So it's very important that you understand how to place opposite, adjacent, and hypotenuse. And the reason why is we're going to learn something today called Soih Cah Toa. Definitely write this down, all right? And we're going to go kind of piece by piece. Now, there's something called a sine ratio. Okay, and you know what? I might do this real quick. I need a little more room. Okay. This might not make complete sense right away. So Kyle, I just got your message. We can talk about it later and double check that and see. Okay, so we have three main trig ratios. We've got sine of angle A. So I want to just point this out right here. When we say A, right, this is my reference angle. So if I drew a picture, it would look like this. This could be A, B, C. And so how do I know which one is my reference angle? It's going to be the one that's right next to the word sine. Now, this is an abbreviation. The actual spelling of sine has an E at the end, but this is just a button that you'd see on your calculator. So it's the sine of angle A, and a lot of times there's parentheses around here. But notice, that's my reference angle. So I'm going to compare the ratio of the opposite leg. So here's the opposite to the hypotenuse. So if I pick the side length CB over the side length CA, that is going to give me what we're going to refer to as the sine ratio. All right, now we're going to abbreviate this. Soih Cah Toa. Where does the S come from? The S stands for sine, the O stands for opposite, and then the H is hypotenuse. So that's the so part. Okay? It's kind of our way to remember these ratios. And then I have something called cosine, which cosine is the adjacent side length over the hypotenuse. And notice it's still of angle A. So if I set this up, now I can use the exact same picture. Angle A is my reference angle, and cosine is going to be this side length AB over this side length, which is the hypotenuse CA. All right, so notice where the K comes from. Cosine is adjacent over hypotenuse. So the first letter is always the sine or the cosine. The second letter is what's in the numerator, and the third letter is what's in the denominator. Right? A lot of students say they call this cos. Well, we say cosine. And there's a reason why it's sine and cosine. Notice co kind of means together. There's a reason why sine and cosine go together, and we're going to explore that a little bit today. And then we have a third ratio called tangent. Right? Tangent is the opposite over the adjacent side. So notice here's the opposite and here's the adjacent, but it's still of that reference angle A. So Toa, Soih Cah Toa, Toa is going to refer to the tangent, which is opposite over adjacent. And you may have heard the word tangent before, especially when people are talking. They say, oh, I'm not to go off on a tangent here, but we'll explore tangent lines. You will explore tangent lines in calculus a ton. So there is a connection to calculus here. But notice, the opposites, hypotenuse, adjacent hypotenuse, and opposite adjacent, that all is based off of the triangle and the reference angle. Every single one of these ratios were based off of this reference angle A. So notice, if I switched this to reference angle C, the hypotenuse would stay the same, but the opposite and the adjacent, those would have to switch, and that would change. It wouldn't change the meanings, but it would change their outcomes. And we'll see that in a second. Okay, why do we need to know trigonometry? What is the point of it? And that's what we're going to learn here. Okay, so don't write this part here, and I'll get to your question in just a second, but I want to show you just how do we set up these ratios really quick. Now, first thing you have to notice is we've got sines and we've got cosines, and I just want to set up the ratio. So how do I know what ratio to start from? Well, it depends on the angle of reference. So here, they're telling me that I have to look at angle A. And the first thing I'm going to do is identify what the pieces are. Now notice we have 3 side lengths. That's cool. We can identify the longest side length as the hypotenuse. And then I'm going to follow across from the angle of reference, across from A, is my opposite side. And next to the angle A is the adjacent. So now, if I'm going to do the sine ratio, sine is going to be the opposite. And here's what I always write this, Soih Cah Toa. All right, so what is sine? Sine is the opposite over the hypotenuse. Right? And I'm still not getting at why we know this or why this is useful. We're still used to just setting it up. Then I'll prove why it's helpful. All right, so what is sine? Well, sine is the ratio of the opposite side over the hypotenuse. So see how it's 24 over 40? And then we always reduce that down. You just reduce it down to 3/5. So then what is cosine? Right, well, let's look at cosine. Cosine is Cah, the adjacent over the hypotenuse. And what did we label adjacent? As 32 over hypotenuse, which is 40. So 32 over 40 reduces down to 4/5. And then what is tangent? Tangent is the Toa. That's the opposite over the adjacent. All right, so opposite we labeled as 24, adjacent we labeled as 32. And there is the ratio for tangent, opposite over adjacent. But the part I wanted to show you is what happens now if I switch my thinking. What if I change my reference angle and I say, oh, you know what? I want to actually do sine, cosine, and tangent of the other acute angle. We will never do the ratios of 90 degrees. And the reason why I can't do 90 degrees is if I have 90 degrees, then the hypotenuse also becomes the opposite, and they can't have the two labels on one side. So that's the reason why we never use 90. There's more to it, but for right now, that's all we kind of need to know. So let's take a look at this. What if I change, let's use blue. What if I change my thinking? Now, what happens? I want the sine of angle C. Well, sine is the opposite over hypotenuse. All right, but I changed my reference angle, which means now we have to kind of focus on the color. If I do angle C, the 32 is now the blue side is opposite. The hypotenuse is always going to remain the hypotenuse, but now the opposite turned into the adjacent. So see how those switch when you're changing your reference angle? Well, the ratios aren't going to change. Sine is still opposite over hypotenuse. Cosine is still adjacent over hypotenuse. And tangent is still opposite over adjacent. All right, so now let's just look. Well, what is the sine of reference angle C? It's the opposite, 32, over the hypotenuse, which is 40. 32 over 40, that can be reduced. Cosine is the adjacent over the hypotenuse. That's 24 over 40, which reduces down. And then opposite over adjacent, that is 32 over 24. And then just notice something here really quick. If I take the cosine of angle A, see how that's the same as the sine of angle C? And if I take the sine of angle A, 3/5 is the same as the cosine of C. That's just a little connection. And then look at tangent and cotangent. They're reciprocals of one another. All right, so you didn't have to write that down. But now let me show you why. Okay, why do we need to know this? It sounds like somebody just made up these ratios and it doesn't seem great or fun to use. Actually, you know what? Sorry, I forgot about this problem. I'm gonna skip this problem. I don't want you to write it down because it's the same thing we just did, but notice we have one tiny problem. Okay? If I want to calculate the sine, cosine, and tangent ratios for both acute angles. So I got to do angle A, sine, cosine, and and tangent. So I got to do that for A, and then I have to do it again for C, because that's the other angle. So notice how this is the same thing we just talked about. I don't think we need to write this, but we have one tiny problem. The tiny problem is I know what sine is, right? Sine is the opposite over the hypotenuse. I know what cosine is. It's the adjacent over the hypotenuse. And I know what tangent is. That's TOA, opposite over adjacent. Well, if I want to set this up, okay, here's angle A. Across from angle A is always going to be the opposite. So I know what the opposite is. But I don't know what the hypotenuse is. Uh-oh, what do we do? Well, I know two sides of a right triangle. You may have to do some work here quick. And the nice thing is if you have two sides of a right triangle, I just added these two together. We can take the square root and you might have to reduce it down or break down, but notice if I know two sides, Pythagorean theorem will automatically help me find the third side. So now across from the 90 is the hypotenuse, and across from attached to the reference angle is the adjacent. So now I'm able to set up everything opposite over hypotenuse, and then we should reduce this down. I believe this is 15/17, right? And then cosine is 16 is the adjacent, 34 is the hypotenuse, and then if we divide this by 2, we get 8/17, and then the tangent is the opposite over the adjacent. And if we reduce that down, that gives me 15/8. All right, then we could redo everything for C. We don't have to do that. The only reason why I wanted to show you this problem is right here. What happens if you don't know one of the sides? Anytime you have a right triangle and you know two sides, you can do Pythagorean theorem. Okay, now I'll get to the question, why do we need to know this? Okay, well, let's think about what we've been doing so far. And I definitely want you to write this one down. This is the reason why we're doing Soih Cah Toa or trigonometry. What does trigonometry do for us? Well, trigonometry allows us to find missing side lengths when we can't use Pythagorean theorem or we can't use the special right triangles that we learned before. Right? Pythagorean theorem only worked when we knew two sides of a right triangle. Well, look at this problem. I only know one side. There's no way I can do Pythagorean theorem right now. It just won't work. And then I cannot use the 30, 60, 90 triangle. Okay? Here's the reason why. This angle's 32. You don't have to write this in here, but if I found this out, this is not a 30, 60, 90 triangle. It's a 32, 58, 90, and that's not one of our special patterns. I'm going to erase the 58 because I want to focus on the angle they give me. So what does this mean? Trigonometry allows us to find missing side lengths with very little information. The only thing we have to know is it has to be a right triangle, and we have to have one side length and the acute angle. All right, so here's what I like to do. This is my reference angle. Okay, and let me know, I'm going to go a little slower because I want you to write this down, but if you need more time, if you need clarification, let me know because this is super important stuff right here. All right, so let's see. If 32 degrees is my reference angle, then I'm going to go right across from that. And the 11 is in the spot of the opposite leg. And then we got to look and see, okay, I want to find the x value. Well, x is the other leg, so that has to be the adjacent one. All right, now, notice they don't tell me to find the hypotenuse, so I really don't care about the hypotenuse for this problem. But what does this tell me to do then? Soih Cah Toa. Now you have to know how to spell that because that's what's going to help us set up the ratios. But I want to look and see, okay, I have Soih Cah Toa. And what do I know? Well, I know the opposite leg. So I have the O, and I want to find the adjacent. I want to find X. So I have O and I have A. Which trig function has the O and the A in it? Well, sine has opposite and hypotenuse, but I don't know the hypotenuse, so I can't use sine, which means I can't use cosine, which means the O and the A tells me I need to use the tangent ratio. That's why Soih Cah Toa is so important, is it just gives us an idea of what ratio we're going to use. So now we have to set things up. What was it? It was the tangent of the reference angle is equal to the opposite leg over the adjacent leg. All right, well, this, whatever was after the tangent, was always the reference angle. So that's going to be 32 degrees. Okay, now I want to pick the opposite ratio. The opposite leg goes on top, so that's the 11. And then the adjacent leg is x. Now, you don't need to write opposite over adjacent because that's not part of the problem. But what we have here is I've got a fraction equaling a number. Now, you might not know it yet, but the tangent to 32 is just a number in our calculator. So what I want to do is I want to solve this by making it a fraction equals a fraction. So let's just kind of pause and take in what we just did. I identified my reference angle, and then I labeled the two sides that I know or want to find, and that was the opposite and the adjacent. Then I used the Soih Cah Toa to find which ratio had the opposite and the adjacent in it, and it was tangent. So then I write tangent of the reference angle, 32 degrees, is equal to the ratio of the opposite over the adjacent, so 11 over x. But then I realized I have a fraction equaling a fraction. So I'm going to have to cross multiply here to solve. And do not grab your calculator yet. We are going to use your calculator, but I got to show something with you. So if I cross multiply, I get x times the tangent of 32 degrees is equal to 1 times 11. So we're just cross multiplying there. Some people like to draw the arrows. All right. And again, what is my goal? My goal is to find the side length x. Okay. Well, if I have x times the tangent of 32 equals 11, now we're going to get x by itself. And we're going to divide both sides by the tangent of 32 degrees. Well, what happens then is tangent of 32 is just a number. So we treat it the same way. So the tangents of 32 is reduce out. And then I'm left with this part right here. 11 divided by the tangent of 32. And now I'm going to grab my calculator. Okay, I'm not sure how many of you have graphing calculators at home. Let me try this here quick. Okay, if you don't have a graphing calculator at home and you have a school Chromebook, go to your desktop, and on that Chromebook is an icon that says TI-80V or TI Smart View. You might not have opened that up yet. I'm going to show you here if I can share it. You can see my desktop, but right here this is what my icon looks like. I think yours is the same. But if you click on that, it's going to take a while to open up. but it should eventually give you something that kind of looks like a calculator that I had on my screen. Now, you don't have to use the online one. I actually don't like the online one because it pauses sometimes and it freezes up. If you have your own, use that for sure. But we have to check one thing. We have to check the mode of your calculator. Okay, so what I'm going to do now is I'm going to hit mode. You can see that red where it lights up in red. And then I'm going to scroll down to the one where it says radians/degrees. Now, for us, we are in 32 degrees, right? So our tangent is the degree measure. So you need to just go down and go over and hit enter and see how that kind of darkens there. So I highlighted the degree, and you technically only need to do that once. But if you're using the calculator on your Chromebook, I would check that often every time you open it because I'm not sure if it resets. I think it doesn't, but you just want to be safe. If you're in the wrong mode, everything else that we're going to do here is going to be wrong. All right, so what we're going to do is we're going to, once you did that, just go second quit, and that will bring you to a new screen. Okay. Now, I want to take 11 divided by the tangent of 32. Yep, somebody just asked if we could do that again. It's really quick. So hit mode, and then you're going to go down to the spot where it says radian and degrees and press over so the degree is highlighted and hit enter. And that'll just, what that does is it puts your calculator in degrees mode. You should always check that. If you ever borrow somebody's calculator, make sure that it's in degrees mode. All right, so now what we're going to do is we're going to take 11 divided by the tangent button. Now here's where if you have a non-graphing calculator, you may or may not have the tangent button on there. So we have to find it, but that's the one that just says tan. And then we have to type in the 32 degrees, and it will start the parentheses. You should always end it after the 32. All right, now, here's what you can do. If you do not get the exact same answer I do, that means that your calculator is in the wrong mode. So if you don't get 17.6036, that means you are probably in the wrong mode. And we got to figure out how to get your calculator into the right mode. All right, so I just did a screenshot of mine. And some of you may have specific questions with your calculator, and I will do my best to help you navigate through that. Please do not hesitate to ask a question when that comes up. All right, how do you switch to radial? So we aren't going to use radian. Do we round our answer? That's a phenomenal question. Yes, you round your answer. You have to take it to 3 decimals. So what that means is the 6 is going to round this 3 up to a 4. So 604. My answer, the missing side length that I wanted to find is 17.604. Okay, now you do not round to just, you don't call this 17.6. If you do, you're not going to get full credit. And to be honest, you won't really see the reason why until we get to calculus. So you have to wait a couple of years as to see why do we always round to the 3rd decimal spot. And it really has to do with accuracy. I will say unfortunately, our textbook will round to the 1st decimal spot, but we always want to be better than that, and we want to round to the 3rd decimal spot every time. Okay? Let's see. So I think, I'm not positive, but somebody asked, how do we switch to radian degrees? If you want to switch to radians, you just go back. Now, we don't want to do this this year. We're not going to use radians. Everything we do this year is in degrees. So if you just keep it in degrees, you'll be good. All right, let's try another problem, because it's always my experience that students need a couple of problems just to kind of feel comfortable with this. Keep in mind, what did we just find? We did just find that x is 17.064. Now, I will point this out really quickly. If I take that answer and the opposite answer, I could do Pythagorean theorem if I wanted to find the hypotenuse, or I could do sine or cosine to find the hypotenuse as well. So now we have more ways to find side lengths of triangles, and that gets at, why are we doing this? Why is trigonometry important? Trigonometry is what allows us to find the side lengths of any measure. It doesn't have to be a special right triangle. All right, so let's write this one down. And we are going to rely on our calculator as well. So now, a couple things to notice. They want us to find two different side lengths now. So I see this and I think I have to do two separate problems. But the first thing that I always do is indicate, what is my reference angle? It's 21 degrees. All right, and then from that, I always follow and I look for what number did they give me. Well, in this case, they actually give me the opposite leg. And really, I just write OPP. I just write opposite. Okay, now we get to pick. Do you want to find y first or do you want to find x? It doesn't matter. Let's find x first, just so we're all on the same page. Well, what position is the x in? It's across from the 90-degree angle, so it's in the hypotenuse. Right? Now, if I'm going to do this, you'll notice this. I write this for every problem that I do, so I don't ever forget it. Soih Cah Toa. All right, what do we know? We know the opposite side, so that means I'm going to use either sine or tangent, because I'm going to use the one that's have the O in it. But they want me to find the hypotenuse side. So the only ratio that has both the opposite and the hypotenuse is the sine function. So that's how we know which ratio to use, and that's extremely important. I hope everybody's comfortable with how we identify that we're going to use sine. Now, what is it? It's the sine ratio of the reference angle. So the 21 degrees is going to go right here. And that has to equal the ratio of opposite over hypotenuse. So I have to figure out what's the opposite and what's the hypotenuse. And then we're going to put those side lengths in the correct spots for the ratio. All right, well, across from the 21 is 34. That's the opposite. And across from the 90 is x. That's the hypotenuse. Notice it's almost the exact same setup as what we did with tangent. The only difference is it's a different part in my, it's a different button in my calculator. So now I have a fraction equaling the sine of 21. Let's turn that into a fraction so we can cross multiply. I'm going to pause here. Any questions? Because this is, if you can get here, I feel like everything else is just algebra. Okay. So just quick, we looked at 21, we saw we had the opposite, and I decided to solve for x first, so that's why I have the hypotenuse. So O and H is so, which is sine is opposite over hypotenuse. Now we're going to cross multiply. So I'm going to do 1 times 34. It doesn't matter which part comes first. I could put 34 on this side. And then I'm going to do x times the sine of 21 degrees. All right, so it's the same work then. I want to get x by itself. So I'm going to divide by sine of 21, both sides. And the sines of 21s are just numbers, right? It's our calculator tells us that number, but we're just going to leave it as sine of 21. And now grab your calculator and do the same work we just did, except for now it's 34 divided by the sine of 21. Okay, I'll show you that in just a second. So I'm going to go back. You can clear your screen, or you can just start with where you're at. But I've got 34 divided by the sine of 21. Now this should automatically be in degrees mode because we didn't change it. We didn't do anything to our calculator. And there you go. I'm going to just capture this screen. Oops, that's not cool. And then again, we want to always round to 3 decimals. So just make sure your rounding is right where it needs to be. So take the third decimal here, the 4. Because there's a 5 there, it's going to round up. So I get 94.875. Okay, I like to go back and add that to my answer. Okay, if you can't get that answer, so a couple people had said, I don't get that answer. My guess is that you will make sure it's 34 divided by the sine of 21. If you typed in exactly what I did, then it's the mode on your calculator. And if it's not a TI-84, or if it's not a TI calculator and you can't hit mode, and actually go to the degree and change it, then you and I are going to have to talk, and maybe we do that right at the end of class here, is you show me your calculator and I try to help you figure out what mode you're in. What you can do though is you can, for now, hopefully if you have a Chromebook, you can use your Chromebook and that should have this same computer. It might look a little different, but it should have a calculator simulator on there. But if not, we're going to have to touch base after class sometime. But for now, just kind of watch what we're doing. Okay, we're not done with this problem though, and that's the important thing to note. We have to find y. I'm going to use a separate color here so you can kind of see how I'm thinking about this. I have 2 options. Actually, I've got more than 2. I could do Pythagorean theorem. I could take my answer and do Pythagorean theorem. But to be honest, I think that's a lot more work, and I want to focus on practicing the skills that I know. So let's look at this. The y is in the adjacent value. All right, if the y is the adjacent side, I could use my answer here, but this is not a friendly answer, and what if I made a mistake? So my advice is use the answer they give you. So now I'm looking at, if I want to take the 34, that's the opposite, and the y is the adjacent. So O and A, I'm going to do the tangent ratio right now. Okay, so this work over here will be to find y. So I'm going to take the tangent of the angle measure 21. We always do the reference angle. And that's going to equal the ratio of the opposite over the adjacent. So you don't have to write the word opposite over adjacent, but I recommend doing that because then it's 34 y. And then it's the same work. I'm going to let you in on a big secret. Okay, you can skip some steps here because watch what's going to happen. We're always, anytime the variable is here, like what if I have this? 1/2 equals 4/8. Okay, don't write this part here, but what if I just switch the spot of the 1 and the 8? So what if I call this, if I just switch the y and the tangent, or the 8 and the 1, does that still produce an accurate answer? Is 8 divided by 2 equal to 4/1? Yeah, they're equal to the same thing, which means I can just switch the locations of these. Now, if you don't like this, you don't have to do it. You can cross multiply. It'll work the same way. But what if I switch the y and the tangent? So this is y/1 and 34 over tangent of 21. I'll make that look like a y. Notice, well, wait a minute. Y divided by 1 is still y. And then all I have to do is grab my calculator and do 34 divided by the tangent of 21. So try that. And when you're done, rounded to 3 decimal spots. Ooh, I got to check my mode. I just grabbed my handheld calculator. I get 88.573. And that's the other side length here. So now we know all 3 sides. We could find this angle if we wanted to. Okay. Now we did do one, or unfortunately, all of these had the x or the y in the denominator. What happens if it's not in the denominator? I think I got a problem like that. I'm not positive. I'm just going to show you that on a separate slide here really quick. All right, don't write this. I just want to show it to you quick. What if I made up an example that I said tangent of 27 is equal to x over 13? Okay, how would I solve this? Because switching the 13 and the tangent doesn't help us. Well, look at this. When the variable is on top, we're still going to cross multiply. 1 times x is equal to 13 times the tangent of 27. So when the x is on top, you still are going to cross multiply, but it's not a divide by the tangent. Now it's a times by the tangent. And if I just grabbed my calculator, this answer would be right here. So we just didn't have one set up that way, but this is kind of actually an easier piece because you're just multiplying 13 times the tangent of 27 and x times 1, and those have to be equal. So, okay, we got one more thing that I definitely want to get to, and it's word problems here. So you don't have to write this whole sentence, okay? And actually, maybe you don't even want to draw this picture. But we're going to explain what do we mean about angle of elevation versus angle of depression. Because those are two pieces that it's like, how do we get a right triangle from all this information and then use Soih Cah Toa? So from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. So let's stop from that sentence. Right here, there's a fire ranger in the tower. And if the fire ranger was normally looking straight out, her line of sight would be straight across. But she looks down at an angle of 40 degrees. So when we say the angle of depression is referring to looking down. So her line of sight, or sight line, line of sight, is going down like this, right? So that's the angle of depression. However, what if we change the perspective of this problem? And what if we talk about her her coworker who's on the ground? Well, the coworker would be looking straight across, and their angle of elevation would be the same as her angle of depression. So if you have a person up in the tower and they're looking down at somebody, that person is looking up at the same angle. And the question is why? Why are those two angles the same? That's a very poorly drawn Z. Alternate interior angles, right? They're the same. So, anyways, we have to use these words. I'm going to just stop here and we'll solve this problem in a second. But when you say angle of depression, you can picture somebody originally looking out and then they look down. And that is the angle of depression right there. All right. Now, I think of angle of depression as looking down. Okay. Angle of elevation, I think of it as looking up. So what if a person is walking? Normally they just are staring straight ahead, but then they see a bird fly by. Well, so they look up, and their angle of elevation would be from their original sight line up. So just notice how when you see the word angle of elevation, it's going to be basically like this. When it's angle of depression, the person's looking out and then they look down. Now, sometimes when you see a problem like we have here, if there's somebody on top who's looking out, their angle of depression is the same as somebody on the ground whose angle of elevation, and they're both 40 degrees. So why is that important? Well, that's important because I now have to solve this, and our job is to figure out if the tower is 45 feet tall, how far is the ranger on the ground away from the tower? Well, I don't like to draw my pictures too complicated, so I'm going to call this side 45. I want to find x, and I have the 45-degree angle on the ground. Now notice, I didn't use this piece here. I could have made a triangle like this and then called this length x here, because this x up top is the same as the x on bottom, and this height here is the same as the height 45, but this picture already had a nice triangle drawn. So what do we have? We have my angle of reference. That's the 40 degrees. And the 45 is across from that. So that's the opposite. And I want to find the side length, the leg that makes up the 45 degrees. So that's the adjacent. So I'm going to use Soih Cah Toa, O and A. That's the tangent ratio. And it's the tangent of 40 degrees is equal to the ratio of the opposite side over the adjacent side. And the adjacent we're calling x. And then it's the same work that we did before. So when your variable is on the bottom, you can literally, instead of cross multiplying, you can just switch the spot of the x and the tangent. And that would leave the 45 in its spot and the 1 in its spot. But then this just says, oh, okay, well, x divided by 1 is x, and then use your calculator to figure out what is 45 divided by the tangent of 40. And I know I'm running out of time, so I went a little fast on that. And then since this is referring to feet, because the tower was 45 feet tall, the ranger is 53.629 feet away from the base of the tower. So I hope, my hopes were that throughout all of this, we eventually learned how to use Soih Cah Toa. We learned how to solve it, but more importantly, you figured out why. Why are we doing this? It's more than just setting up ratios. The reason why is because now we can find missing side lengths when we can't use Pythagorean theorem or we don't have a special 30, 60, 90 or 45, 45, 90 triangle. Soih Cah Toa allows us to find any side length for any right triangle and any angle measure here. So this is like your go-to. It works every time that you have a right triangle, an acute angle, and a side. Okay, so I am going to post these notes. So in case you missed anything, you can go back. We did not get to this problem right here. And my only hint with this problem would be to kind of split it up into specific triangles. It's just a multi-step problem, so it's not the end of the world. But your homework tonight is 7.5 and 7.6. All right, so that's all I got. If you feel comfortable with everything that we talked about, then you're in a really good spot. I'll be in my office hours today if you have any questions.